Hello everyone and welcome to my YouTube channel. So in this tutorial we are making a digit classification F using CNN, and we also use the Python module called Keras, TensorFlow and OpenCV, and we also use the Streamlit to make a web application. So let's have a look the demo. So here's the demo, digit classification F using CNN built with Streamlit, Keras, TensorFlow and Python. So let's click on browse file, then choose 1. So let's choose 0 right now. Open. It will still uploading. Okay, it will upload it right now. So let's click on process. Okay, you can see here 0. Okay, so let's click and choose another one. So let's choose 4. It will upload it right now and take some time. Okay, it is loaded. So click on process. So you can see here
number is 4.
So we are going to make this one. Okay, so let's close it right now and also close the terminal. So I already code it here in my Sublime text. So here's my Sublime text here. Okay, so here's a digit classification applications code. Here's line of code. So what are the technique actually you are using? We are using CNN technique called a linear model. Okay, we are using the linear model to make this classification problem. Okay, so let's close it right now. So first we are training our model using Keras, CNN, and then we are making a web application using Streamlit. So first we are importing all the libraries from here. So we are importing the warnings and filter the warnings at ignore, because TensorFlow give me some condition, some warning. Okay, we are trying to ignore it. Then we are importing CB2 for computer vision library. CB2 is a computer vision library, and we are using NumPy here because NumPy will help you to create the multi-dimensional array. And we are also using the OS because we are getting the data from our system. So we are using the Matplotlib for the graphical interface, graphical representation of my data. Then we are using here Scaline for model selection, import the train test split. So we are using the train test split to split the data into train and testing. And we are also using the keras.preprocessing.image import image data generator. So why should we use the image data generator? So basically, image data generator are being used for the data argumentation. If your data, if you have a less number of data, so image data generator will help you to create more amount of data. And finally, we are importing keras.utils.mputils import to category. So each will help you to make the one-hot encoding. Then we are importing the sequential layer, and we also importing keras.layer, importing the convert hoodie and the dense layer and the max pooling layer, activation function, dropout, and the flatten layer. And finally, we are using the optimizer as add-on. So here's the important library. We already imported it here. Then we have to create a variable for path, a string the path. So inside my path is my data. So you can see my data. So it's containing 0 to 9. Okay. So let's click on here, and you can see here in the image of 0, 0, 0, 0. Okay, and the images of 1, so in 1, 1, 1, and it's also same as this one, 4. So which one containing all the images of the number? Okay, then we are making 2 empty arrays. So first one is the images, which will contain the images, and the second one is the class number for levels. And you also put your test ratio. So let's test ratio as 0.2, because when we are splitting the data, we are put here the test ratio as 0.2, and the validation ratio we are put here the 0.2. So as far as we are using the linear model, so that's why you have to put here 32 cross 32. And what is called 3? Because we are dealing with your RGB images. So RGB have a 3 channel RGB. So that's why we put here 3. And 32 by 32 is the image dimension, which take the linear model. So first we are going to create our list of the images, so os.listDir, and you have to put here the path. Then the number of classes we are importing from here. So let's comment it out and run this extension file, right? Okay, this one. So it will give you the number of classes. Okay, so let's run for Control B, and it takes some time. So first it will collecting the data from my data folder. So here's in this my data folder. So here's a 9 folder. Okay, so it will give me 9, I think. Okay, so here's it. So it's first list the dir. I mean, listDir is using for listing the dir function. Okay, and it will get it, and you can see using TensorFlow backend as a Keras, because you are using a Keras library from TensorFlow. So TensorFlow provides a backend called Keras. So it will using this TensorFlow backend, and it will importing all the library right now. Okay, it takes some time, and it also upon on your system. Then it will listing this data from here inside my path. Okay, okay, we forget to print it out here. Okay, so print the number of classes. Okay, and run it again. So you can see here the number of classes. I think it will take some time because TensorFlow is so heavy, and I am using my CPU, so that's why it's giving some time. Okay, so you can see here 10. So why 10? 0 to 9, so 10 classes. So it will give me the 10 classes. So let's commit it out here, and now we have to read all the data and we are making this we are what do you call let's go here. We are working. Okay, so here is it. Okay, so here is it. Okay, so we are create a list. First we are creating the list here 0 to 9, so 10 classes. We are using the len function to what do you call for length. Okay, now we are importing all the classes, then we are resizing it at 32 by 32. Okay, because we are using the linear model, so linear model says your image have to be 30 cross 32, 32 cross 32. Okay, so first we have to create a loop to iterate all the number of the classes from the my data here. So for x in range, we are putting here a condition here. So 0 to number of classes, we are already using the len function, we give it here. Okay, length of the classes. Then we are making a listDir, so which will help you to go to this path. So go to like this. So my data, then go to the 0 folder, then it will iterate the images right now. Okay, so os.listDir. So first it will list the path from path my data, then the backslash, so backslash and string x. So what is the x actually? So x will go to when it iterated all the value. So first time it will go here 0, the second time it will go here 1, and third time it will go here 2. So after 9 here. Okay, so then it go here the 0 folder, then it will iterate all the value from the my pick list. So that's why you have to use a nested loop here. So for why in my pick list, we are reading the data using a CB2 have a built-in function called cb2.imread, so which will help you to extract all the data from here. So for why in my pick list, we are put here the cb2.imread and the path name and the backslash. So backslash will help you to jump to the folder here. So first it will give the folder as x. So x means 0 folder, so 0 folder, then it will give a backslash, and for y means the pick list. I mean this is one pick. Okay, then we are going to resize our image. So CB2 have a built-in library called cb2.resize. Okay, so that also you have to pass here the current image, I mean the source, then the image dimension. So image dimension here we already declare it here, image dimension 32 cross 32 and 3 channel. So we are using only 2 so 32 cross 32 cross. Then we also append it here in our empty list. Okay, we already create the empty list for images and the class number. So we are put here in the class name from the images, and the class number you append the x number. So x number means this is a classes. Okay, which you iterate from here. Okay, then finally we are going to print it out here. Okay, Now it's time to create our NumPy array. Okay, so we have to convert our image into a NumPy array. So that's why using the NumPy.array function and also add the class number. Okay, so if I make it comment out and run it again, then okay, so you can see here it will importing the TensorFlow backend, then it will be listing all the dudes from the directory from my data, then it will reading all the classes. So you can see importing classes. I put here a message, and it will importing all the classes. Okay, and first it will read the images, then make the images into 32 cross 32 cross images. Okay, so it will importing all the classes right now. So here you can see 0. Okay, so let's close it right now. Then we are going to make our image into a NumPy array. Okay, so then after converting our image into a NumPy array, so what we are going to do right now, so we are splitting the data into train, test, and split. So we already import our library here from sklearn.model selection. We are importing the train, test, and split. Okay, so which one help you to divide your data into train and testing? Okay, so first we are using this one. So xtrain, xtest, and ytrain and ytest. So using the train test split function, you have to put here the image and the class number. And the test ratio you already declared it here, so 0.2. Then we also make this one for the validation. Okay, so xtrain and x validation and ytrain and y validation. So you have to put here the xtrain and also the ytrain into the validation part, and you also put here the test ratio, the validation ratio, which you'll already declared here 0.2. Okay, then it's time to check it the sample, what are the sample, what the image contain right now. So for x in range 0 to number of the classes, okay, we are appending all the classes in the number of sample. Okay, so it will help you to see what kind of data inside this here. I mean what number of images from this folder here. Okay, so I will plot a diagram and plot a visualization. So it will help you to make the distribution of make the distribution of the images. Okay, so if I run this program in our, let's comment it out. Okay, then let's run in our CMD. Okay, CMD. So first copy out from here, Ctrl C, then CMD. Okay, and call python.py. So it is running and takes some time, so let's minimize it right now. Okay, so it takes some time for running. So first it will importing the TensorFlow backend, then importing all the classes and reading the images using the CB2 format. Then it will resize our image 32 cross 32. Then it will give me a distribution plot of the images which containing. Okay, so you can see here using TensorFlow backend, and it will importing all the classes and reading all the images here. So let's look our images first. So my data, then 0 here. Okay, so here the images of 0. Okay, 0,000 of images, I think, of zeros. I think it will be running. Why should it running? Alright. And the images of 1. So here the images of 1,000 of images. Okay, 1,000 of images of 1 and 2. Here is our data. I'll give you a drive link, you can download it from here. Okay, So why it takes some time importing all the classes right now. So let's minimize it right now. After completing it will give me some. Okay, so now it's time to pre-process our data. So let's meet. Okay, so after it will give me the distribution plot. You can see here some distribution plot of the classes. Okay, it takes some time. Okay, importing all the classes, 9 classes right now. Okay, 9 no, 10 classes. Okay, so first we have to convert our image into a BGR to GRAY format. So that's why we are using the cb2.cbt color image, and we have to put here cb2.color BGR to gray. So we all what do you call, we put here a RGB image, or you can see here BGR image. So first we have to create this, convert this image into a grayscale. Okay, then we are put here a equalize his. Okay, then we are normalize our image. So why should we put here 255? I mean divided by 255, because 255 will help you to create the normalization. I mean, what is the normalization like this? Normalization is the range of 0 to 1 like this. So you are first we are making the image into a numpy array, then we are train, test and split the data, then we have to put we are making our image into grayscale image, then using equalize his, then we are normalize our data. So normalize our data means we are converting our data into 0 to 1 format. You know, images are actually what you call in a numpy array. Okay, so I think it takes some time for right now. Okay, so then after pre-processing our data, we have to again pre-process our data from the train, test, also the validation. Okay, we are using this technique in the train, test and validation. So let's comment it over here. Okay, so we are converting our image also in numpy array. Okay, because first you have to import here numpy also. We also already imported here right now. Okay, numpy as array. Then we have to create a map function. So what actually map function do? So map function actually do, it will help you to collect all the data from the X-train, and it will put here the pre-processing. So first we have to you have to memorize all some things. There is some what do you call data structure in Python, map, filters, sets. You have to know all the things. So map will help you to iterate all the data from the X-train, and it will put here the pre-processing, and it will make a list. So after making a list, you will convert the numpy array. So as same as the X-train and also the X validation. So if you are trying to see one pic, you can use this one. Okay, to see this image. Okay, so you are getting here, and then we have to reshape our data. Okay, so why should we have to reshape our data? Because we are using this image in a multi-dimensional array, so you have to reshape our data. That's why machine learning, I mean deep learning model will cast data and train our model. So that's why we have put here X-train shape as 0, Y-train shape and X-train shape 2, and finally 1. So you have to put here 4x4 graph. So first one is the shape of the X-train, and the second one X-train 1 and X-train 2, and finally you have to change it as a 1 format. Then we have to use the data argumentation. Okay, it will importing all the classes, but why not it? Okay, no problem. Just getting some error, but no problem. Okay, so there's okay. Okay, so here is it. Okay, so we are using the image data generator for what do you call, we are getting so more amount of data. It will help you to create the more amount of data in your data set. So using the image data generator, it will help you. Okay, so data argumentation part. So we put here a width shift range 0.1 and the height shift range was 0.2, and is the zoom range as 0.2. So zoom means it will zoom in and also zoom out and rotate and left, and using the shear range and rotation range we put here 10. So and we also feed our data using data generator dot fit. So data generator is update right now. So update of the image data generator, we are fitting our extreme model. Then we have to make our make our Y train and Y test and Y validation into a one hot encoding. So we are importing here. You can see here okay. So keras.utils.mp utils, we are importing the two categorical. So which one help you to make your data in a one hot encoding format or a categorical data. So now it's time to create our model. So we are using the linear model. So here's a two filter. So we are declaring our filter size of filter 5x5 and then another one is the 3x3, and the size of pole we are pulling here 2.2 2x2, and number of node you put here 15, and the filter we are using 60. So first we are declaring our sequential model. So sequential model it is, and we also add the convolution layer, and you put your number of filter and the size of filter one, and you have to put here the input shape. So you already declared our input shape in my declaration part. Okay, so yeah, declaration part 32x32. So we are using this one right now. So input dimension index as 0 and index as 1, and you have to put here 1. So why 1? Because we are reshaping our data in here for one format. Okay, then we are using the activation function as ReLU. So ReLU will help you to active your sequential model. So then we are put here another layer for activation and using a max polling layer. Okay, pole size, put here the size of pole. Oh, we already declared it. So it is the technique of the linear model. You can see it here. Okay, in searching from Google. Okay, then we put here model.add convolution 2D, and the number of filter and the size of filter put here the 2. So we are put here size of filter of 3x3. And activation function is we simply use the rel activation function. So same as this one, and using a max polling layer for pole size. Okay, and you are using a dropout, so which will help you to make your model not overfitting or not underfitting. Okay, so it will save you to your model overfitting problem or the underfitting problem. Then finally you have put here a flatten layer, then a dense layer, and we also put here activation function as well, and you can see here we also put here a dropout. Okay, and finally you have to put here activation of softmax or sigmoid. So it is the input layer. Okay, so dense layer, here the input is first you have to put here the number of classes. So in my case its number of classes 10, and we are compiling our model using the Adam optimizer. So learning that put here 0.001 is what do you call constant, like okay, and loss function using the categorical cross entry. Why actually categorical cross entry? Because we are making our data in the categorical format or one-handed encoding. So that's why you're using the categorical cross entropy. And also 0 1 2 is like a categorical. Okay, and matrix, we are using the accuracy matrix. And finally we are return our model. So and we call our function, not a function actually, it's all we call all of them math. Okay, then math model. So model equal my model, and we are printing the summary of the model. And finally it's time to fit our model. Okay, so model.fit generator and data generator flow from the directory, and flow the data from X train and Y train, and the batch size we put here the 50. Okay, and as steps per epoch we put here 2000, and step epochs we are getting from 5 epochs. Okay, and validation data we put here the X validation and Y validation, and the shuffle is 1. 1 means true. If I put here 0, so it will be false. So we are getting here shuffles for random data fit. Okay, and finally you are saving our data, not saving data, not saving our model using model.save. Okay, so if we run this program, okay, save it and go to here and type cmd. Okay, then python .py. Okay, no source file in the directory problem. Okay, sorry, put it here, cmd python and the file name .py. So it will first importing all the classes, and then okay. So first it will importing all the classes and put into a variable number of classes. Then it will iterate all the value and put into a list here, and it will make a path. Go to this path, and it will all the it will iterate all the pick from my pick list into this y, and we are reading the image using cb2.imbit function. Then we resize our image from the linear model, because you are using the linear model. So at the documentation, you have to put here 32 cross 32. Okay, so that's why you put here the current image. Then the dimension, we already declare it here in a tuple format. Then we have to append it, the image, into what do you call my image list, and we also put here the class number in our class number list. Then we are converting our image into a NumPy array and also the class number. Then we are splitting the data in a train using the train test split function. Then you also put your test ratio as 0.2, and you also validate our data using same method. Then we are printing we are collecting number of the sample from this folder and make a list. Inside this list we are appending all the data, where y and p dot where y is equal x, and the list will be 0. So here you can see the distribution of the images. Okay, so it will, I think, running down. Okay, distribution of the images, it is the distribution plot. Okay, so if I close this one, and it will you can see here is a my model.summary is my model summary. Okay, and it will going here the epochs. Okay, so I already trained it in my system already. It takes some time, and it's upon on your system, so I am using CPS, so it's getting some more time in my case. So let's close it out right now. Okay, so after training our model, you can find here model.s5 file. So here this, so my training model.s5 file. So this one will help you to detect your digit. Okay, so here is it. Then we are creating what do you call, okay, this one. Okay, so then we are preprocessing our images. Okay, preprocessing our images, cb2.cbt color, and make this image into grayscale format. Then using the equalize hist, we using the equalize hist to make this equalize, and divide by 255 for normalization. Then we are iterating all the value from the xtrain, and validation, and put into the preprocessing function using the max function, and we are converting into a list. Then we are finally converting into a NumPy array. Then we are reshape it in a format of this one. Okay, and then we are create an object for image data generator. So here's the image data generator object. So width shift and height shift range, we use the zoom range and the shear range and the rotation range. And finally the feed the data using data generator or feed function, and inside this parameter put here the xtrain. Then we are make our target, I mean label data into a categorical, I mean one-hot encoding, the categorical format using this one. And we are creating our filter, not a filter actually, define our model. Then inside this model we are initially our filter is 16. The size of filter we are put here 5x5, and the filter number 2 you put here 3x3, and the pole number you put here 2x2, and the number of node you put here 15. And now we are create our sequential layer and create a convolution layer. Okay, and using the activation function as ReLU, then create the number filter, then put here a max pooling layer, and it's same as this one, and we divide it by 2 at the filter size, and using a max pooling layer, and we also put here a dropout, so which can help you to help you for overfitting and underfitting problem. And you put here a flatten layer and a dense layer also be, and again you using a dropout layer. Okay, then finally you the input layer and the branch layer and activation function as softmax. And finally you are compiling our model using the Atom optimizer. The learning rate at 0.001 and the loss is using the categorical cross entropy, and the metrics are using the accuracy matrix. Then we are call our my model function, then print our summary, then feed the data using the model.feed generator function, then put here the data flow from this here. So we are flowing from data gen because we are augmenting our image already. Okay, so flow from here, then put your x train, y train, and base is put here 50, and step for epoch we have put here 2000, and the epoch we put here 5, and the validation data put here x validation and y validation, and the shuffle is 1, which means true. And finally you are save our model using the model.save function. So now it's time to create our web application. So here's the code of the my web application. So it's simple. So it's time to create our application right now. So first we have to importing the warnings and filter the warnings because TensorFlow give me some warning error. So you are trying to ignore it. Okay, and we are also importing the Streamlit as st and importing the NumPy as npim because NumPy is help you to create multi-dimensional array, and using the field library called Phylum, and we are importing the image and image nh, and you also importing the width, so which will help you to get the data from our system. Then you're importing the CB2, so CB2 will help you to read the data and show the data, show the images. Then you also import the Keras model, so it will help you to root our model. We also put here a Win32com plot client discuss, so which will help you to make a artificial voice. Okay, so let's move it on. Okay, now we have to create a model object. We are loading our model using my model.s5. Okay, so after training your model, you can find here s5 folder, not a folder actually, s5 file. So which one? The model file. Okay, so now we have to pre-processing our data. So we are creating we are defining a function so for pre-processing, so which one help you to pre-process our data. So in our training part, we also define a function like this. So you have to put here also this one. Okay, so what we use the try and except block. Okay, so when you run this program, okay, you have to put here a RGB image. So if you use here a grayscale image, so it will give you some error. Okay, for example, I choose here a grayscale image. So you can see here we converting our image into a BGR to gray. If I put here a grayscale image, so why should it convert this image into grayscale? So it will totally wrong. So if I get a grayscale image, so it will go here the extraction part and it will convert the grayscale into a BGR format. Then it will convert this image BGR to and then gray. Okay, I think you will understand. Okay, so using the CB2 color image and CB2 the color BGR to gray. Okay, so I'll put here. Okay, after running this program, you will be. Then we will define a function for the Streamlit application. So we put here st.title, digit classification apps using CNN. We'll do the Streamlit Keras and Python as a sub header, or you can also call it right. Okay. And the set option, we are setting some option because file uploader give me some error. Okay, so that's why you put here in this one. Okay, and activities classification and about. So this about for me, and chose we have put here a sidebar using the select box, and we put here the activities. So you put select classification, it will go with classification. So if I put select about, then it will go my about. Then we if we choose the classification, we put here a subheader of digit classification. Let's run it right now, and you can easily this one. Okay, you can easily get all these. Okay, stream lead run and disable. So this one. So let's take some time after running. Okay. It's better to run our program than understand all the things from here. Okay. So it will open your local host. You can say using TensorFlow backend. It will be reloading right now. So in my case is the Firefox. So it will opening my Firefox browser. Okay. So it will opening and takes some time because you know TensorFlow is so heavy. Okay, Streamlight, it will be still processing. Okay, so you can see here activities, two activities. So one is the classification, another is the about. Okay, so if you click here about, you can see here my about. Okay, this application developed by Mishul Chandu and my picture. Okay, so let's put it here. Classification. So okay, running. Okay. So if I comment out this line and save it for Control S, reload this line again, so you can see here why should we use this line. Okay, right now it will be running. Okay, it's not give me some error. Okay, but sometimes it give me error. But I don't know. Okay, so the classification and the sidebar choice st.sidebar, the select box, select activities and activities. So why should you put here the select sidebar? So here is the sidebar. Okay, so select activities, it is a sidebar. So if I close here, it will be gone. If I put click in here, it will be classification. So it have built-in library. Still, it is so cool. Okay, so st.sidebar, we are selecting a box from the activities. We are creating a list of the activities. So in my case, is by classification and the about. Okay, so then if I chose the classification, it will go here this one. If I chose here the about function, it will goes here. Okay. So first we put here st.subheader, the digit classification. So it is the subheader, digit classification, and upload file. So you have to put here uploader, file uploader, create a file uploader. So image file st.file uploader, Streamlight. We was already put it here, Streamlight. Okay, so here is it. So st.file uploader. So upload file, and the type is the PNG, JPG, and JPG. So it is the file format of our image. So if the image file is none, it's not none. We are opening our image using a Pillow library. So we are importing from it here already. Okay. So from Pillow we are importing the images. So image will help you to open our image. So image.open. You can also use the CB2 library, but Pillow library is also very compatible. And we put here the st.image. We are shown our image in our web application. So using the st.image. So if anyone click the process button, so it will go here. Okay. So that's all. Okay. So we also create here a try exception block, because after it will cause us some error. Okay. If you put here like this picture of person, so it will give me some error. So first we have to convert our image into array. Okay. So that's why using the np.asArray as a app image. So this is my app image, and we are resizing our image into 32 cross 32, because we already discussed about this one, because we are using the Leiden model. That's why you have to resize our image 32 cross 32. Then we are calling our preprocessing function to preprocess our image. So you already make it here. Okay. Then we have to reshape our image this style. Okay. So this is style, we have to reshape our image. Then we are using the model.predict function. So we declared our model. So load our model here. So using model equal to load model. So this one, and we are loading the model and predict it. Then we are predicted the classes and the probability value. So NP have a function which will help you to create the probability value. So np.argmax and the prediction. Okay. So if the probability is 90% up, so it will give you the correct output. Or you can also put here the 0.5. Okay, so let's put it down as 0.5. It's up to you. Okay, but 90% is right, correct. Okay, so if the class index is 0, so you can say here the folder. Okay, so if the class index is 0, means this one the class index of the 0, so it will be 0. So the class index is 1, this means it go to this folder, this 1. So the predicted number is 1. Okay, so if you use a pick function to make it artificial. Okay, so first you have to import this one, this library. So this library is help you to create artificial voice. Okay, then speak equal to dispatch and the speak.speak voice and speak.speak and the put here the parameter is text. Okay, then this one, so it also same as the all classes, 0 to 9 classes, class index equal to 9, st.success equal to 9, and the speak and predicted number is 9. Okay, so if it getting some exceptions, so st.error, connection problem, I'll refresh again, that's it. Okay, this is mine. So let's take something. Okay, so let's say print error. So why should we give this one? You can see here. Okay, let's save it and reload it again and choose a grayscale image. Okay, grayscale image mean we are okay, cannot interpret dictionary key as of a placeholder. But what the problem? It's getting some error. That some error. Okay, the problem is some. Let's save it. Actually, it's mean it's some error of the grayscale image. That's mean if I run this program again, refresh it. Okay, or it takes some error because of some Python is so naughty. So if you put here a grayscale image, okay, for example, if you put here a grayscale image, so it will go here this one, mean this function. So it will put here this parameter and check it is a grayscale image or not. So that's mean we are training our model. So inside this model we already initialize that is this image must be a RGB image. If I put here a grayscale image, so this will give me some error. Okay, this will give me some error. So that's why we put here try and except block. So if you put here a grayscale image, so first we are converting it to visual image, then the grayscale image. If you put here a RGB image, so that's fine. Okay, so that's it. Okay, so that's the code. So I will put all the code from a GitHub link. You can download it from here and check it. Okay, so now it's time to run our program. Okay, let's reload it again. Okay, now you can hear something different, artificial voice pop from empty listing. What the sound error? Save it and run it again. It's better. Okay, something give me some error. Not Python stream late .py. Okay, streamlet.mlog.py. Python is so nutty, it takes some time because he's using the interpreter. It's so slow. Okay, I can set it. So it will open in your local host. Okay, take some time and be patient. When it is loading right now, streamlit hell command agrees. No, oh, okay, I'm getting some mistake. Stream later run, then the file name. Okay, this one, streamlit run mlweb.app. That's why it give me error. Okay, it will open in localhost. Using the TensorFlow backend, you can use this one. Okay, let's copy out from here. I think it will already open it right now. Okay, opening Streamlight. Okay, so let's choose image from here. Okay, so let's choose again 0. Okay, so this time I open my, click on open, then click on process. So after processing the image, then click on process. So connection problem or refresh again something problem, getting some exception. Okay, so let's save it right now and reload it. I don't know why not it, why it giving some error. Okay, our place is empty right now. Start the image right now. Flow from the directory. What the problem? So let me check it out. Okay, I think I am not saving right now. Okay, this one. Okay, reload it again. Just getting me error, but what the error, I don't know. Cannot interpret a dictionary tensor placeholder, this one, but why? So let's close it again. Okay, it takes some time. Let's type it. Okay, try catch, no problem, but it will give me, but why it will give me error, don't know. So let's run it again. Streamlit run ml. Okay, copy out from here. Actually in my system it's getting some error, but it's still running in my case the first time. Okay, wish it will be running this time. Okay, it's opening the local host. I think it will be some problem of the, I think I'm told the terminal, I think. Okay, it will be running. Also be digit classification apps using CNN. Click on browse file and this one and this one. So it will be uploaded the file. Click on process. Okay, I got the problem actually. Okay, I got the problem. Okay, I am forgetting to connect my internet because cause of it will using, I will using a Win32 com.client file. So that's why it will give me the error. Okay, I got it. Okay, no problem. So here's the tutorial. So thank you guys for watching this video and make sure to subscribe my channel and don't forget to hit the bell icon for never missing an update, and bye bye.